All right, let's get started. Okay, so today is the deadline for PS 11A, and last I looked, 95 students hadn't done it. So all you got to do is go sign up for your group for PS 11, either with a partner or with yourself. But even if you're working by yourself, you need to sign up as a group of one. If you do it today, you get 5 points. If you don't do it today, you don't get the 5 points, but you still got to do it. Yeah?
That's just on the website that you put a private link to. We don't have to do anything after we sign up on that.
Right, there's nothing to submit.
Okay.
You just follow my link, sign up for your group, and you're done. Yeah?
After you sign up for a partner, you cannot change anything.
You can't what?
Like after you sign up, you can't change any partners anymore, right?
You know, you can't. If you signed up and need to change, just let me know. I can change things, but there's no way for you to delete a group. Okay, and then this morning the appointment slots for next week's PS 11, whatever it is, C or something, B, must be B.
Yeah.
Were made available, and a lot of people started signing up for those. So next week, you and your partner, or just you, if you don't have a partner, need to meet with a TA and show progress, which means you look at the rubric for PS 11, there's a bunch of things you have to do. We want you to demo 4 of them next week. So there's nothing to submit.
Be on time.
What's that?
Be on time.
Yeah, all you have to do is be on time. And you just show the TA what you got, and the TA will check you off. Then there's a progress report, just a short little survey due at the end of next week, and on we go. Any questions or problems before we start? Yeah?
For any class that we change, should we make a specific test class to test that, or should we make one general?
Okay, so he's asking if he changes a class, should he make a test for it? You know, in a perfect world, yeah, you should make tests for the classes, but I'm not going to expect you to do that at all, because it's hard to make tests for such a visual program. So there are ways to automate tests for things like this, but for our purposes, just play the game, and that's your testing. Okay, yeah?
I noticed that there's a participant state of Java class in the Asteroids.game package, and there's a method called get participants using an object called iterator. And I searched it in Google, and I found. So my question is, what's the difference between an iterator and a for each loop?
Okay, so he sees a method that returns an iterator object. And he's asking essentially what that is. If I'm not mistaken, a for each loop consumes an iterator. Well, I'll try that out once we get to the coding part of the day. Any other questions? Yeah?
Yeah. Why do you have to import some classes like constants as static?
Okay, so he's asking about static imports. Okay, so this is right here on the screen right now. There's this little this picture that has there's a class called constants that defines all kinds of constants. So when you import into a file, let's see if I can find something here. When you do an import, what are you importing? Are you importing a package? Are you importing a statement? What? Each of those import statements, what does it name? Yeah? Well, it's a set, but each one of those things is a class. So we're importing java.util.hashset, so we're importing a class. We import java.util.iterator, class. So when you import something, you import classes. Now, what would happen if you imported Asteroids game.constants. Okay, we've imported that class, right? Now, if we want to use one of the constants from that class, what do we have to say? Okay, let's look at the picture again. Let's say we want to use size right there, or title. How would we access title? Whoops. How would we access title from inside of code? Let me get this back. Where was I? Right here. Okay? Let's say I'm in this method and I want to access title. What do I have to type to get title out of the constants class? Yep.
We need new constants dot title.
Right. You have to say constants dot title. And then you can do something with it. Okay? You get tired of doing constants.title. You get to the point where you wish you could just say title. And so the way you can do that is you do a static import. And when you do a static import, you're not importing a class. You're importing all the static things from inside of a class. So you can use them without qualification. So normally you import a class, well, enough said. So simplest way is just to import every constant from the class. So a static import lets you access the constants and the methods in the class without qualifying with a class name. So that's the difference. Yeah?
I noticed that in the lights out game, in the C4 class, and stuff like that. I'm certain how that was done.
Right. So yeah, you can simplify your C4, your Connect 4 game by doing static import on classes that contain constants. Yeah.
If you had an instance variable in this class called title, which one would it use? Or would you not be able to?
You wouldn't be able. Static import ignores instance variables. It lets you access any static thing. A static.
Right, but in this class, if you had another, you couldn't use that same.
Oh, if this class had something called title.
Yeah.
Yeah. Let's try that. So it is,
So it defaults to the class it's in.
right. So typically when there's variable name conflicts, it'll take the closest declaration. So it refers to the title declared in the class to the title declared in another class. That's what it appears to be doing. Okay. Any other questions before I? Okay, what I'm going to do today is just give you a tour of the Asteroids program, the version that I gave you. And I'm not going to show you how to do exactly, the tasks that you need to do for the project. But I'm going to try to, we'll make some changes to the program and just sort of get you moving in the right direction. And so, questions are very welcome as always. They're especially important today because I want to tell you the things that you're wondering about. And the place I'm going to start is with this picture I've been showing you. Now, this is actually an image file, and I can, which means I can zoom in and out. It's called a class diagram. There's a set of standards called the Unified Modeling Language that describe ways of creating diagrams that describe programs. And so this is a diagram that lets you take a bird's eye view of all the classes in the Asteroids program and how they interrelate. Now the way I created it was I found a plugin, and the way the plugin works is you create a new, it's called a UCLS file. So you create a new UCLS file, and then you can just pick classes, which I'm doing here, and drag them into over here, and it creates the diagram for you. Now, unfortunately, when it does that, it doesn't lay it out in a particularly pleasing fashion. You can see all the lines are crossing. And so I took a lot of time and and arranged them just so, and I saved my file. And then I closed the file, and I may have restarted Eclipse, but what I found out is that when I went to reopen this file I had saved, now it's still there, but when I restarted Eclipse, it was empty. So I don't recommend this program. Fortunately, I made an image of it, of the file I just showed you before I did all that, so we can look at the image. Oh, okay. All right, we're talking here about a production problem. So you need a few minutes to fix it? Okay, go ahead. All right, so we were sending a low definition signal to YouTube, which is going to make it hard for the majority of the class to see what I'm presenting on the screen. So let's Stefan fix things for a second. Okay, we're back. Okay, so each box here corresponds to a class in the program. So you can see asteroids, and then participant, constants, and so on. If you look at participant, you'll see that at the very top here, let me zoom in. You see speed x, speed y, rotation, x, y, border, expired, and they're these little boxes. Anyway, those are all private instance variables. So the private instance variables show up here at the top. No private instance variables in the asteroids class. And then you see down here are methods. So you see all the methods provided by the participant class. Over here are all the methods provided by the asteroids class. And the annotations tell you whether they're public, protected, static, whatever. I don't know exactly what the coding is. There are arrows. So for example, down here, the asteroid class implements the ship destroyer interface. And so this type of arrow means we implement an interface. The asteroid class also extends the participant class. And so we have a different sort of arrow, a solid arrow with that triangle head as opposed to a dotted arrow with a triangle head. In this case over here, a participant countdown timer has an instance variable called payload and an instance variable called timer. It also has an instance variable called participant, but that one is shown graphically because that's another class in the diagram. So we have this arrow that comes over from participant countdown timer and it says there's an instance variable called participant that is a participant object. So that's what all the lines mean that hook things together. So the nice thing about this is it just gives us a way, something for me to point to as we're discussing the class. Something graphical you can look at as opposed to having to glean everything from the code. So let's start with this first class up here, asteroids. So there's a constructor, there is a method called main, and there's a method called choose version. So it's not too hard to figure out what that class is for. It's just the main method that launches everything. Now, one thing I want to make sure you understand is that when you run asteroids, you're asked which version you'd like to run. So if I click classic, I want to see the exact version I asked you to implement that emulates the asteroids.jar I gave you. On the other hand, if you click enhanced, that's where you put stuff for extra credit. Okay? So when we grade your asteroids program, we'll grade PS11 just on classic, and we'll give you extra credit based on enhanced. And the extra credit, of course, is optional. And, you know, we used to just have one program, but then it became hard to separate out what was an extra credit thing and what was a mistake, honestly. You know, people could leave stuff out and then say, oh, but that's a feature, not a bug. So we have two versions. Yeah.
How do we need to separate have separate files?
Okay, so he's asking how to separate. ideally, you wouldn't make 2 separate copies. You'd want the extra credit version and the classic version to share things that haven't changed. So what does that imply? Let's suppose you have a ship class, and for extra credit, you want to have a fancier ship class. What would you do? Yeah?
Say in your code, like wherever you're going to display the ship, if like you'd have an enhanced variable, and if enhanced is false, you show the original ship. If enhanced
Okay, so you'd have to decide which version of ship I want to show, but how would you implement the extended ship? Yeah?
Have the fancy ship extended.
Right. The simplest way is to, instead of copying the ship class and modifying it, just use inheritance. Have the extended ship extend the ship class with differences. Okay? So you can use these polymorphic ideas to make writing your extended version simpler. Okay, so that's the main class. That's not a very interesting class. The most interesting class, for my money, is participant. And you see the name is in italics right here, participant. That means it's an abstract class. So we got this abstract class called participant, and you've looked at the program. You had the lab yesterday. What is the participant class? What does it buy you? Why is there a participant? What does participant mean? Go ahead.
it has all of the objects in the game that share similar methods and instance variables, so all of the participants in the game.
Yeah, it's all the participants in the game. So if we start the game here, there are two participants. There are two things on the screen. There's a ship, and there's an asteroid. If the ship could fire bullets, the bullets would be participants. If there was an alien ship, it would be a participant. If there's a missile, the missile's a participant. Anything flying around on the screen is a participant. Now, what do all participants have in common? Yeah? Okay, so they have, all participants are moving, so the participant object's got to keep track of the velocity of the, in the X and Y directions of the participant. What else?
Object interaction?
Okay, what happens when the participant can collide with another? What happens when they collide? Yeah, you were going to say that same thing. Okay, they have they can be accelerated in a direction which may actually slow it down. So there are lots of things that participants do, and they're all these methods control how participants behave. So let me zoom in a little bit here, and you can see you can expire a participant. That's how you get it off the screen. You can test if it's expired. You can set its velocity, its direction, its speed, its rotation. You can cause it to accelerate. You can apply friction to it. You can set its position. You can get information about it, and so on. So there are lots of these, lots of methods that control the participant. So the participant class crystallizes everything that all participants have in common. And that means if you want a particular participant, such as a ship, you extend the participant class. So there's asteroid, which extends participant class, and here is ship, which extends participant class. So as you add new things to the game, you're going to extend the participant class. Now, I mentioned that you can, that this is an abstract class. So you can see right here, there's a method called getOutline that's marked, it's italicized and it has that funny symbol with an A. That and collided with are abstract methods. So this is an abstract class that contains abstract methods, and I think that's probably the only ones. So when you extend the class to create, say, an asteroid, you have to provide a getOutline method and a collided with method. You know, so that because you're extending an abstract class. That's the minimum you have to do to get something to work on the screen. Just those two things. And you don't have to worry about the physics of how things move, because that's all written in the asteroids class, in the participant class already. Now I want to switch and look at the participant class, because I'm going to make a point about object-oriented programming. Okay, so here is participant. And I mentioned there was this abstract method called getOutline, right? So let's find getOutline. Okay, so you see getOutline right there. But look right there, there's a move method in the participant class that calls getOutline. So I have written code in the participant class that uses an abstract method. The method doesn't exist, and yet I'm calling it. Now let's see if I call it anywhere else. Okay, I call it right there in draw. Okay, so there's the abstract method, and I call it in 2 places. Okay, there's the method collided with. It's abstract, and I don't call it anywhere. So what do you think of this method here, which is not only non-existent, but is actually called in the code for this class? How can that work? How can the code for this method call a non-existent, this class call a non-existent method? Yeah?
Because you're not calling that method, you're calling the implemented version of it.
Okay, so he said we're not, in the end, when this program runs, no one is going to be able to create a new participant because it's abstract. They'll either create a new ship or a new asteroid, and it provides, it overrides getOutline. So this the code in this class that call getOutline, when it actually runs, it's going to call the overridden method. So this is a common technique when you create a type hierarchy, a framework like this. Abstract classes that have and use abstract methods under the knowledge that they'll be overridden before they're actually called at runtime. Okay, so if you want to do, you may have a need to change the participant class. Maybe you decide for, especially if you do it for extra credit things. It's the central class, and if there are certain effects you might want to achieve where you need to modify the class. I'm not sure you need to modify it for the classic version. I can't quite remember, but it's a good one to understand. But for the most part, you won't be modifying the participant class. You just need to be familiar with what it provides. You'll be extending it, like I said. So what does getOutline do? When you extend the thing, you've got to know what these methods are that you're overriding. So who could tell me what getOutline does? You can read the comment there. But what's the bottom line here? What's the purpose of a getOutline method? Yeah.
I guess the shape of the participant.
Right. It returns the shape of the thing. So the getOutline method for the ship returns the ship shape. It's used to draw the thing on the screen. And the outline for the asteroid is the same thing. It's what you use to draw the various asteroids. What about collided with? Yeah?
Doesn't it take the idea of the outline and compare it to other outlines?
Okay, so what she said was it takes the outline of, it finds out if 2 outlines have intersected. Like if the ship outline has intersected with the asteroid's outline. So there is code doing that. But basically, when the system detects that 2 things have collided, that 2 shapes overlap, it calls the collided with method on each of those shapes, on each of those objects. So when it detects that the ship and the asteroids overlap, my code will call collided with on the ship and say, you collided with this thing here, the asteroid. And vice versa. It'll call the asteroid and say, you collided with the ship. And those objects decide what to do about it. Yeah?
So does that mean you have to have like a statement for each participant that you have in each type?
Well, let's look and see what it, okay. I can answer that question just by showing you, let's look at the ship class. So here's a ship class. You can see that it extends participant and implements asteroid destroyer. So this is the technique that I use. First of all, here's the constructor which creates, this is creating the shape of the ship. Took some trial and error to get that right. This method returns the x-coordinate of the nose of the ship, which is important because that's where the bullets come out. You don't want the bullets to come out from the middle. You want to come out from the nose. And this gives the x-coordinate and the y-coordinate of the nose. This returns the outline. So that's the overridden method. So it creates the outline and saves it, and just returns it. Then I have various ways to manipulate it, but the question was about collided with right here. So the way I settled on dealing with collisions is, for each type of participant, I created an interface for it. So ship has an interface called ship destroyer. Asteroid has an interface called asteroid destroyer. These interfaces contain no methods. They're called marker interfaces. And it just gives you a way to test. So essentially, if I'm a ship and I'm told I collided with a participant P, I see if that thing is a ship destroyer. And if it is a ship destroyer, then I got to do something. And what I do is I expire the ship, and I tell the controller that I've been destroyed, because the controller needs to know when a ship has been destroyed. Now, what could I change about asteroids to make ships impervious? So here's the asteroids class. No, it's the wrong one. The asteroid class. What change could I make to this so that asteroids would not destroy ships? Yeah?
You could take out implement ship destroyer.
Exactly. So I just do this. So an asteroid is no longer a ship destroyer. So let's try and see what happens. Okay. I just sort of have to get a collision by luck because this, all I can do is turn right. Okay, so the asteroid was destroyed because the ship is still an asteroid destroyer, but the ship wasn't affected. So you don't have to, I did that to avoid having to have a long list of, okay, I got to check, did I hit an asteroid? Did I hit a bullet? Did I hit an alien ship? And so on. Instead of doing that, I just have things that destroy ships are going to all implement that interface. And then I just got to check to see, am I a ship destroyer? Is that thing a ship destroyer? Okay. So let's go back to the diagram.
Joe, I want to point out that they could have multiple implementations.
Okay, so Stefan asked me to point out that, you know, an asteroid is a ship destroyer, but it's also an alien ship destroyer. And it's also a bullet destroyer. The bullet hits an asteroid, the bullet's destroyed along with the asteroid. So that just means that asteroid's going to have to implement multiple destroyer interfaces, and that's okay, because you can implement multiple interfaces. You say implements something, comma, something, comma, something. Okay, so the participant class is key. The participant state class, on the other hand, you really don't need to go into it. You're welcome to look at it. It's the most intricately coded, and any bugs I've found over the years of mine have been in participant state. So if you go in and start changing it, you might create bugs. So basically what I did was I tried to factor out the stuff you really don't need to touch into participant state. So you can just sort of take it for granted. Okay, we talked about participant there. We can maybe come back up for questions. But this class here, this is one you've got to get really familiar with, controller. Now, why do I say that? With a name like that, what does the controller class do? Yeah? Right, it's basically controls the whole user interface. So, you know, when keys are pressed or buttons are pressed or whatever you have, it's the thing that learns about it and takes the appropriate actions. So it's worth looking at in detail. So let's let me dig that up. And so you can see what it's keeping track of. It's keeping track of a participant state object. Because it keeps track of the ship. And we can talk about a refresh timer and the transition time another time. It keeps track of the number of lives that are left, and it keeps track of the display. The display is the area where the action is taking place. So it doesn't have that many instance variables. But of course, it's stripped down as well. So as you add things to the game, a lot of your work is going to be done in the controller class. So let's, so I have a method called splash screen right here that clears the screen and sets the legend and places 4 asteroids near the corners of the screen. So that's called to set up the game. It's only placing 1. The final screen is what displays the game is over. This is code that places a ship. It expires the old ship, it creates a new one, adds it to the game, and clears the legend. So these are just actions that can take place. This places an asteroid. It's supposed to place 1 near the corner of the screen, but it actually places just 1 right now. Let's add another one. Okay? So what would happen if we just did this? Add 1 more asteroid to the screen. Now those parameters, what do they mean? The first is the variety. There are different sizes. No, I'm sorry. 2 is the size. 0 is, there are 4 different shapes asteroids come in. And this is the place you put it, and that next parameter is the speed. Okay? So we, what do you predict the game will look like when I add a new asteroid? Yeah? Yeah, so they'll spawn in the same location because we told it right here where to put it. So let's see. Okay, they spawn in the same place, but then they diverged, which you might not have been expecting. Why'd they diverge? Yeah. Right, the asteroid constructor gives a random velocity. We tell the speed, but the velocity also, basically, it picks a random direction and goes in that direction at the given speed. And rotation, because you see, they're rotated slightly differently. Okay? We can clear the screen. This sets up the initial screen. This is for adding a new participant. So there are all these methods in here that manipulate the screen in various ways, implement the rules of the game, implement the user interface. Here's the action perform method. So you know all about action perform methods. So this one, there are 2 things that can call the action performed method. One is if the button is pressed. So if the start game is pressed, we start a new game. That's what initial screen does. The other thing it can be is there is a refresh timer. So there's a timer I create that about every 30th of a second it calls action performed. And that's what controls the progress of the game. So every 30th of a second this refresh timer fires off. So let's go to the declaration up here. There's where we declare it, and here we initialize it. So frame interval controls how often it goes off, and frame interval is 33 milliseconds. So every 33 milliseconds this fires off. And let's see what we do every time that timer goes off. Lost. Okay? We do this. So basically, perform transition, its job is to figure out, is it time to go to the next level, say? Or was the ship, or is it time for the game to end? It just checks to see if major events have been happening. This asks the p-state to move all the participants, simulate the passage of 33 milliseconds. And so it applies the rotations and the velocities and checks for collisions and such. Takes care of the motion. And then we refresh the display. The display redisplays all the participants in their new locations. So what would happen if I took this out? Yeah? Yeah, nothing would update, nothing would move. So I run it, I start it, and things don't even get their initial location. Not that they just don't move, they don't even show up. Now what if I did something like this? Let's say, refresh timer dot get delay. So what if I said if refresh timer dot get delay mod 1000 equals 0. Okay, so get delay is the time in milliseconds. No, that's not what I want. I want the current time. That's what I want, current time in millis. Okay, so current time in milliseconds just tells us the wall clock time, what time it is in milliseconds. And what I'm going to say is if the current time in milliseconds mod 1000 is equal to 0, then I move the participants. So what's that going to do? Yeah?
It'll only move everything once every second, I believe. Because it's...
Yeah, it would only move things every second, but
every full millisecond on the system.
Every full millisecond, so it may not move very often at all. Let's try it and see.
For every full second.
Yeah, it's only going to move things when the current time is exactly on the second, which isn't okay. So that's okay. I should have thought this out ahead of time. Let's do this. We'll take the time mod 1000 and see if it's less than 500. So about half the time it ought to move the participants. So you see, we're not calling it half the time, and so you get that effect. On the other hand, what if you always move the participant, but you only refresh the screen half the time? So before they were moving and stopping, moving and stopping. Now you see they're jumping. Because we've continued to update their position, but we're not displaying it. And so it jumped periodically. So anyway, that's the refresh timer is I call it the heartbeat of the program. If you want something to happen smoothly, like the animation, or the turning of a ship, or the firing of bullets, it needs to be keyed to the refresh time, not to external events. Okay? So things that have to happen smoothly need to happen in sync with the refresh timer. So you'll definitely be coming in and changing what happens when the refresh timer goes off. Yeah?
What happens if we got rid of the refresh timer and just add those three methods calling themselves?
Okay, so he was saying, what would happen if we, instead of calling this method every 33 milliseconds, we just had a loop that called it continuously? I'm not going to change the program to do that right now, but what would it look like if we just called it on a tight loop instead of every 33 milliseconds? It would move really fast, right? plus the rate at which the game, so it would move really fast because we'd be calling it far more frequently. But the other thing that would happen is, as this method here, move participants, the more participants that are on the screen, the longer it takes to move all the participants around, because it's got to do, you know, a lot of math to figure all this out. And so if we didn't have this leisurely refresh cycle, the game would be noticeably laggy. You know, it would play really fast, and then as there are more participants, it wouldn't be quite as fast. It would slow down, and it could still be pretty fast. The hope is that you can take care of moving everything and refresh the screen inside of 33 milliseconds. If you can't, your game will be laggy too. Yeah.
So for the button, you would usually have like button.add action listener, and every time you click the button, it would call the action event, right?
Right. So somewhere there's code that adds the controller as an action listener for the button.
But for the timer, do you have to add the action listener to the timer as well?
Well, the way the timer works is, here's the timer constructor. We tell it how often the timer should fire an event, and we give it this as an action listener. So the constructor takes care of registering, remembering who to notify when the frame interval ends. Okay? Now there are lots of details, but what I've given you here so far is the big picture. No, that's the small picture. So let's just see what we've touched on so far. We have the Asteroids class, which is, this is the main method. Participant countdown timer, we need to talk about. Participant class, that's a key thing that all participants have in common. We have participant state, which you really don't need to look into unless you really want to. We have asteroid and ship currently, which are concrete examples of participants. You'll be having many more, or several more. We have these interfaces, ship destroyer, asteroid destroyer. We have the controller class, which controls the whole user experience. And we have display and screen. So forget which is which, but one of them is the whole window, and the other is one of them is the whole window, including the button up here. The other is just this black area here. So offhand, I can't remember. Okay, and then finally we've got up here. We just have a bunch of constants. Now, most of those constants are not used in the program. Why are they there? Yeah?
So that we can use them in our implementation.
So that you can use them in your implementation. So what I did was, when I created Asteroids, I created the whole program, did the best I could, and then I started taking stuff out. But I left the comments behind. And I didn't take, well, what I should say is I didn't take the constants away, even though they're not being used, because I deleted the code that used it. But I left the comments in. So if you're wondering how fast should or let's say how often what's the speed limit of a ship? What's that, speed limit? Okay? So when you have decisions to make about how fast things ought to be, how big they ought to be, and so on, look here first before you just make up your own numbers, because you can probably figure out what numbers I had in mind in my game. Yeah.
So does that mean for the classic version we won't be needing to add any more constants?
He's asking for the classic version you won't have to add any more constants. Yeah, that's what it means, unless you do something. I mean, it's possible you do things differently than me in these constants. Maybe you need new constants, but in principle, yeah, you shouldn't have to add new constants. Okay, so far we have a high-level view. I know there are things that students get confused about, like participant countdown timers. and certain things that go on inside the controller. So let's take a break for a few minutes, and then we will, I want to look in more detail at some of the things we get the most questions about. Okay, let's get started again. A lot of times you find yourself in a game where, let's take an alien ship for example. The way an alien ship works is it flies in from one side of the screen and it changes direction every second, I believe. Okay, alien ship flies in from the side of the screen, and every second it makes a decision whether to go straight across the screen, to go upward at a 1 radian angle, or down at a 1 radian angle. So every second it has to decide what to do. And it's also firing bullets, so every now and then it wants to fire a bullet. So the way that my code is designed to handle that are participant countdown timers. So essentially, you can start a timer and say, in 1 second, fire an event, cause something to happen. So you can imagine having a timer that went off every second, and the alien ship would change its direction at that second. Okay? So let's invent a new participant and use a timer to control its behavior. So what I'm going to do is I'll come to the participants right here, and I will create a new class, and I'm going to call it thing, And superclass, job.length, well, I'll just, yep.
Question?
Oh, question,
Online.
yep, go ahead.
It says, can we change the value of the constants if we think that the speed limit is too fast?
Well, okay. If it's too fast for you to play, you know, when you hand it in, it needs to be as much like the original game as possible. But it's fine to slow things down while you're debugging. Let me add another thing. We have this experience of students that will say, you know, I have a bug on level 3 of the game. Let me show you. And so they'll start the game up and they'll win level 1 and then they'll die on level 2 and then they'll start the game up again and it takes them 10 minutes to get to level 3 to show us the bug. So there are a couple things you can do about that. One is you could just change your code to start the game on level 3. So, or you can temporarily make your ship impervious to anything, right? That way you just make it so it ignores when it gets collided by things, and then you can just plow through anything and get to any level you want to. So don't be afraid to put cheats in to.
Or delete all your asteroids except one.
Yeah. Just put one asteroid on a level, and maybe only one that's really small, so you kill it and you're on the next level. So you can be creative that way while you're debugging. Okay, so we want thing to extend participant. And we need to import it. And now it's going to complain that we need to add unimplemented methods. So we've got to have a method that returns its outline and a method that does something when it collides with another participant. Well, I don't want to do anything when it collides with a participant, except maybe we'll have it print something out. Okay? We need to return its outline. How do we do that? But what code do we need to do to create the outline? Yeah?
Make it a constructor.
We can make it in the constructor and then return it. But how do we make it? Yeah?
Copy the code from like ship or asteroid and then just change it.
Yeah, so we could go see how I did it here. So right here what I did was, so that's there. We'll go back to thing here. I'll see what happens if I just create it and return it in here. Okay.
You didn't copy the last one.
So what if I do that? Okay. What's my thing going to look like? Yeah, it's going to look like a ship. Okay? So we need a different one. So we could modify this. There are other ways to create shapes, though. So we're using a class called path2d.double. Let's see what else we can do. Java dot. Okay, we've got this thing called ellipse 2D. So let's try that. Import that. So you're not restricted to drawing things with points and lines. I'm going to give it an x coordinate of 0, a y coordinate of 0. I'm going to give it a width of 100 and a height of 200. So that's also a shape. Okay, so shape is an interface, or an abstract class, I'm not sure which. There are various other classes that implement that interface, and one of them is ellipse2d.double. So I'm going to create a circular looking, an oval looking thing. Okay? Now, what should we, do we need a constructor? Don't have any instance variables. I don't think we need a constructor. How do we get this thing into the game now that we've created it? Where in the code will we go to insert a thing into the game? Yeah?
Is there an add participant method?
Say what?
Is there an add participant method?
There's an add participant method, yes. And the question is where we would call it from. So the controller seems like a good place. So let's find, right? When we add the ship, when we place the ship, we add a participant. So I'll be lazy here and I'll just say when we add at the same time we add a ship, we're going to add a new thing. So let's import that. All right, so every time we place a ship, we're going to place a thing. Now really I should have a place thing method and call it from somewhere, but I'm kind of in a hurry. Okay, so what do you predict will happen when we run it? What will we see? Yeah?
It's just going to be a circle oval thing that's going to sit there.
Right, it's just going to be an oval thing that just sits there. So let's, well, I haven't tried this out, so let's see. We'll see what happens. Okay, so the oval thing is just sitting there. How can we make it move? Yeah?
In the ship class and the asteroid class, you have a velocity function.
Okay. So let's do this. Let's do thing. We'll create a new thing. We will add that thing as a participant. And then let's say t dot set speed. I don't know what's a good speed.
Speed limit.
Speed limit? Okay. We'll have it move at the speed limit. Okay? So now let's see what happens when we run it. That's not so fast. Okay? Now, how can we make it so that it wiped out asteroids? So we got this friendly oval that's going to clear asteroids for us. How do we make it? Yeah? Okay, we make it an asteroid killer. Notice, I didn't notice this when it was running, but it was printing out every time it collided with something. All right, so we'll go back to thing here, and we will make it an asteroid destroyer. And I guess I need to import that. Excellent. No, it kills the asteroid right away because it's sitting on top of the asteroid. That wasn't so interesting. Maybe we'll make it a ship destroyer instead.
Please change where it starts, change the position.
Okay, change where it starts. So let's go back to the controller here, and let's say t dot. Oops. There's a position, so let's put it at. I'm not sure what the right place is. 300, 300, let's say.
There we go.
Okay? Now, what if we would like it to get smaller with time? what if every second we want to shrink? Think about that for a second. So I want it so that it flies around and every second it shrinks a little bit. And then another second it shrinks. So how can we arrange for something to happen every second? Yeah?
We need a participant countdown timer.
Right, we need a participant countdown timer. So we can set up a participant countdown timer that'll fire off every second, and then we can, every second we can reduce our size. So let's go to thing. So I'm going to create an instance variable. And it's still running. Private int width, and we'll start the width being, let's see, which is which here. First one is width. So we'll make width 100. We'll make the height 200. And I'll use width and height right here. Okay, how can we set up a participant countdown timer? Where do we do that? Any ideas? When should we start the clock? Yeah?
Within the constructor.
Yeah, it's logical to put it in the constructor. So let's create a constructor. Right now we just have the default constructor that does nothing. So I'm going to create public thing. And we're going to say, we want to create a new participant countdown timer. That's imported. And it wants a participant, which is us, so we'll say this, and it wants a time in milliseconds. So every 1,000 milliseconds, we want it to do something. So we'll create a new participant countdown timer. We don't even have to store it anywhere. We just have to create it. We don't need to save it, because it'll just run until it doesn't need to run anymore. The question, though, is what happens every 1,000 milliseconds? Surely we got to do something other than call something, how do we know? Well, yeah, every time it fires off, we're going to reduce width and height. But how do we know the timer is going off? Yeah?
So is that, there's an action listener and control, right?
There's something. So we need to go to the class here. And we'll see that participant countdown timer, yeah, action performed. So we need to implement an action perform method. So let's go back here. And every time it's called, we're going to do something like width equals width minus width times 10%. Except these are ints. It's too bad.
I'm quite sure you're right there. I think you have to do the method countdown complete. Action.
Okay. Am I messing up here?
Yeah,
Let's look at participant countdown.
See, it calls the countdown complete method.
Oh, you're right. This is internal. Action perform is internal. It implements action listener. Thank you, Stefan, for saving me. Okay, it makes the callback. Where is the countdown complete method?
Got to put it in there.
Oh, it's right here. Okay, so when it happens, it's calling the countdown complete method. So I am sorry about that. Let's go back to thing here.
And it passes a payload.
Yeah. Okay. Yep. So the countdown, the participant countdown timer uses action events internally, action perform methods. But our job is to override the countdown complete method. So this countdown complete method will be called every time the participant countdown timer sees that a second has gone by. And when that happens, we will change the width and the height. Now, given the way I created the countdown timer, this parameter will be null. But I could, if I want to, I can pass any object right here. Except I put it in the wrong place. I'm not sure. One of the parameters can be any object, and it's passed every time to countdown complete. That could be useful in certain circumstances. You need to get information every time to the method. We don't need it here. So now it ought to work. Yeah? No. Good question. Let's run it and see what happens. Okay, so I think it got it only does it once. So the next thing we have to do is start a new timer.
Just change the fields in thing.
Okay, so you see it's shrinking. So that's the idea behind a participant countdown timer. It's a way to do timing on objects, on participants that you have. And you see, it didn't, we changed the game quite a bit, but it really didn't take much work to do it. Took some work on my memory to remember how participant countdown timers work. But fundamentally, we return the outline, and that just depends on the width and height instance variables. We're not doing anything when we collide. And every time the countdown complete, we reduce the width and the height, and we start a new timer, so it'll continue. Okay, so in the 9 minutes I have left, I can think of one other thing to show you, but I want to see what questions you have, because they're probably more important. Yeah?
So is countdown complete inherited from the participant class?
Yes, participant implements a version of, so if we went to participant class, it has a countdown complete method that does nothing, so we're overriding it.
So when you create a new countdown timer, how does it know which countdown complete to call? Is it just whichever class you created it, call that one?
Okay, so when we create it, the first parameter is the participant to invoke the method on, which in this case is the thing itself. Got a question there?
I have a question online. You already answered it, but maybe you want to elaborate more.
Okay.
What is the object payload? How can we think about it?
Okay. I sort of put that in for completeness. I'm not sure that I can think of an example where it would be useful right now. Yeah. Well, I want to finish this question. If I thought you might have an answer for me. The idea is that when at the point where you create, let me just try to remember what order it goes in. Okay. So what that means is that when the timer goes off, that second parameter, if it's there, will be passed as the payload. And we can look at it and do something. So we could do this, for example. We could say, first time, and down here we could say, other. Okay? So now we could do something like if typing very well today. If the payload equals we could do something differently the first time this bear with me here. Okay, so if the payload is first, we know that's the first time we've been called, and maybe we shrink it by a lot. And all the other times, the payload is going to be the string other, and so we reduce it the other way. Yeah?
Can I give an example?
Yeah.
When I first created that payload, it's for the alien ship. So some participant countdown timers were for shooting and some were for turning.
Okay.
So the payload told what we're going to do
Okay.
at that point.
All right, so what Stefan just said is, imagine you have multiple countdown timers for the same alien ship. One controls firing, one controls motion. So you could use the payload to distinguish. Let's see if I've done this right here. So you see it shrunk a lot, and then it starts to shrink slowly. Use the payload to decide what it was doing. Other questions? You had one that I shut down.
Okay. For the classes you showed us, is that are those the main ones we're going to basically modify?
Yeah, the classes you'll be modifying, I mean, the controller is the one you'll be modifying the most. But then you'll be creating lots of participants. Right? You'll create a bullet class, and an alien bullet class, and an alien class, and so on. All right, I want to show you one more thing in the 5 minutes I have left. If we go to the controller, okay, we've talked about the refresh timer. I have transition time here. So here's the deal. As the game is going on, let's say the ship destroys the last asteroid. It doesn't immediately go to the next level. That would be kind of jarring. Instead, you destroy the last asteroid and sort of things continue for a few seconds, and then you're in the next level. Or maybe the ship gets destroyed for the last time. All the lives are done. And so, again, you want there to be a decent interval of time, and then the splash screen comes up that says the game is over. So you can schedule transitions with the transition time is my idea. So let me just show you how it's used. So to clear the transition time is a time in milliseconds since January 1st, 1970, which is how such things are measured. So it's just the current time in milliseconds. And so when I say transition time way into the future, what that means is something's going to happen when we reach the transition time. We're not going to reach the longest possible long. So that's how you arrange for there to be no transition. Okay? To schedule a transition, we set the transition time to some number of milliseconds beyond the current time in milliseconds. So if you want something to happen 5 seconds from now in the game, you set the transition time to current time plus 500. Okay? And every time the screen is refreshed, every time the refresh cycle happens, the code calls perform transition. And what it does is it checks to see, has the transition time reached the current time? Has the current time reached the transition time yet? If it has, then it's got to figure out what to do. And the only thing that can happen currently is it says, if there are no lives left, the game is over. Okay? So you'll be modifying that method to perform other transitions. The reason I did it this way is because you've got this scenario where you're playing the game and you fire a bullet and the ship is destroyed. But that bullet hits an asteroid and ends the level. So now two things have happened. And so the way the code would work was that when the ship is destroyed, it'll schedule a transition to bring the ship back on the same level. But then when the asteroid is destroyed, it will set a transition time a little bit further in the future to deal with the fact that you've destroyed all the asteroids. And it's up to the code here in perform transition to figure out what to do next. Yeah?
If we create a method that needs to be called on every updated frame, where do we like do that?
Okay, if you want something to be called on every frame, we find in the action perform method right here. This code right here is executed every frame. Or alternatively, you could just add a you can add up the refresh timer. Simplest answer, there may be other ways to do it. Simplest answer is to put it there. Other questions? Yeah.
So if you want like an alien ship to do like multiple things at different times, would it be better to use like transition time or multiple?
Well, no, the transition time is there for the controller only. It's just a way so the controller can space things out. For participant time, you use a participant countdown timer, not the transition
Just
time.
like multiple ones, so like every 10 seconds it like drops a bomb, and like
Yeah.
every few seconds.
Yeah, you could have multiple countdown timers. Yeah, when it said look at the name. Transition time is meant to time when major transitions happen in the game. It just worked out to be the simplest way I could think of to do that. I'll give you one last piece of advice. Keep in mind that this program was one that I wrote, and then I just started deleting stuff. So it was originally a fairly well-structured program. So if you find yourself not being able to, writing ever more complicated and obscure code, trying to replicate the way the original game behaved, you're probably doing it wrong, because the original wasn't, it was longer, but it wasn't particularly complicated. So just keep in mind that there's a way to do it.
Don't change your code, just add to it.
Yeah. And don't go into participant state and start changing things, or you'll regret it. Okay? We'll stop here. Have a great Thanksgiving. Remember to do PS11A today.